Hey guys, we're going to be wrapping up Chapter 7 here with Section 8, talking about geometric sequences. So you want to pause and copy this whole thing down. It says a geometric sequence is when there is a consistent ratio of any term to its preceding term. Huh? In other words, you multiply by some consistent factor to get the next term. So we'll look at a couple examples of this in a second, but I think this probably makes more sense to you. Multiply by some type of consistent factor. We've already looked at these where can we determine if this is a geometric sequence? You know, is it multiplied from term to term to get to the next term? Make sure you copy this down, these recursive and explicit formulas for a geometric sequence. We've already looked at these for arithmetic sequences. Now we're looking at it for geometric sequence. So make sure that you copy this down. Getting places, dude, that's awesome. I wish I could do that. Man, all right. So let's keep going. Come on, arrow. There we go. All right, so it says, which of the following are geometric sequences? Well, in order to do this, we just have to identify, can I multiply every single term to get to the next term? Well, how do I get from 20 to 200? Well, I can multiply by 10. How do I get from 200 to 2,000? Multiply by 10. How do I get from 2,000 to 20,000? Multiply by 10. And all of these cases, I'm multiplying by 10. So since I'm multiplying by some consistent number, I would say, yes, this is one. How can I get from this to this in terms of multiplication? Well, this is adding 2 every time. I can see that already. So I know that from here to here, I can multiply by 2. Then I'd multiply by 1/2. Then I would multiply by, Then I'd multiply by 1/3. And then I'd multiply by 1/4. So no, this one is not, because it's not being multiplied by a consistent factor to get to this. So no. Down here, what am I doing? Well, 5 times what gives me -5? Well, times -1. -5 times what gives me +5? Times -1. 5 times what gives me -5? Times. So am I multiplying by the same value every time? The answer on this one is yes. All right, where the r in this one would be 10, and then the r in this one would be -1. So that's what we're looking at for those, is just identifying what's the number I'm multiplying by each time. All right, so that's pretty simple. I'm not going to give you a U try on that. Let's go from here. Find the recursive and explicit formula for the sequence. So you want to have those in front of you. I'm going to write those up here right now. All right, so here are my formulas. Here's the recursive, and here is the explicit. Now, all I'm going to do is, first of all, let's identify what is our common ratio. So to get from 7 to 21, 21 to 63, 63 to 89, hopefully you see that this is being multiplied by 3. So what that means is that the r, my common ratio, is 3. The other thing that I have to identify is, what is my first term? Well, in this, that's super easy, right? It's just the first one listed there. So in this case, it's A7. Once I identify these two things, it's just a matter of substituting them into this. So for the recursive formula, remember, on a recursive formula, you identify the first term. And then you just write A of n equals A of n minus 1 times the common ratio. On this one over here, I'm going to have A of n equals my first term, which is 7, times my common ratio, which is 3, to the n minus 1. All right, so here is my explicit formula. Here is my recursive formula. It's just a matter of substituting into these two formulas. So that shouldn't be too bad for you. Here's a couple for you to try. Go ahead and pause. The answers will be up in 3, 2, 1. All right, so here is what I got. Go ahead and check your answers against that. If you did not get those, go back and try to find your mistakes. Let's keep moving here. All right, so using sequences, it says 2 managers at a clothing store created sequences to show the original price and the marked down prices of an item. Write a recursive formula and an explicit formula for each sequence. What will the price of the item be after the 6th markdown? All right, so we'll start with our recursive formula for this first one. Now, first thing I need to do is identify a common ratio. So how do I get from this value to this value to this value to this value? Well, one easy way to do this is to take whatever the second value is and divide it by the first. Take the third value and divide it by the second. In other words, undo that multiplication. So when I do that, when I do 51 divided by 60, I get 0.85. All right, so it looks like this is being discounted 15%. So that's what the markdown was. So this is every single one of these divided by the preceding term equals 0.85. So there is my common ratio. There's my first term. So for the first one, I'd write A1 equals 60. And then I would have, let's see, what is it? A to the n minus 1 times 0.85. Okay, so there is my recursive formula. Then I want to write that as an explicit formula, which is going to be my first term times my common ratio to the n minus 1. And we'll get to this part in a second, but this is the first. Let's go ahead and get the second in here. Now notice here, if I do 52 divided by 60, 52 divided by 60 equals 0.86 repeating. Now if I try the next one, 44 divided by 52, I get 0.846 instead of 0.86. So this does not have a common ratio. In fact, you kind of start seeing here, this is minus 8, minus 8, minus 8. So this one is not going to be a geometric sequence. This is an arithmetic sequence. So we have to think way back to whatever chapter that was. I don't remember what it was off the top of my head. And that's what we're going to be writing on this one, is the arithmetic sequence. So we'll start with our recursive formula, where I identify the first term. So this is A1 equals 60. And then I have A of n equals A of n minus 1. And then this is minus 8 each time. To write that as an explicit formula, it's going to be A of n equals this negative 8 times n minus 1 plus my initial value of 60. Now this is all in your notebook. You'll have to go back. I want to say it's chapter 5, but I'm not exactly positive on that, so you'll want to check. So now I have two explicit formulas. It says, what will the price be of the item after the 6th markdown? Well, you could use this, or you could just continue with this pattern. Let's go ahead and use our equations just to see if they work. So here I have a to the 7th is going to equal 60 times 0.85 to the 7 minus 1, or 85 to the 6. Go ahead and plug that in my calculator. The 7th term, whoops, I don't know why I'm doing the 7th. What will the price be? 1, 2, 3. Hold on here. Let me take a minute to get my bearings. Yeah, this is the 7th markdown because notice this is the first markdown, but it's the second sequence. Second markdown, third sequence. Third markdown, fourth sequence. So the 6th markdown is going to be the 7th in the sequence. So be careful with that because that's a really easy thing to kind of screw up there. The 7th is going to be, after I put that into my calculator, I get about 2263. This one over here to do the 7th sequence is going to be a to the 7 equals negative 8 times 7 minus 1 plus 60. Simplify all that and I get $12. Alright, so here's the prices of the items after the 7th the 6th markdown, which is the 7th term in the sequence. Alright, so let's keep going, writing geometric sequences as functions. It says a geometric sequence has an initial value of 6 and a common ratio of 2. Write a function to represent the sequence. Graph the function. So to write the function, we're going to use the explicit formula, which is an equals a1 times r to the n minus 1. So we're going to say that for this function, we use function notation. F of x is going to equal my first term, initial value of 6, times my common ratio of 2 to the x minus 1. Because I'm writing it in function notation, I'm going to replace that in. So right there is my function that's going to represent this. And then to figure out the graph itself, we'll just go ahead and make a real quick table here. So I have x and y, and we'll put in a couple of values. So let's start with when x is 2. And if I substitute 2 in there, I get 12. If I substitute 3 in, I get 24. If I substitute 4 in, you get 48. And let's go ahead and do 5 too, just for fun. So 5, I get 96. And I should have put in 1, but I didn't. Let's go ahead and do 1. 1 is just going to be your first term, right? So 1 is the 6. You could try that in the formula. 1 minus 1 is 0, so this is going to be 6 times 1. So go ahead and plot these. Now notice here, this is not even close to being big enough. Let's make this go up by 10. So we'll say this is 20, 40, 60, 80, and 100. All right, so 1 is going to be at 6, so it's going to be roughly right here. 2 I had as 12, so that's going to be a little bit above. 3 is 24. 4 was 48, so I'm getting close to 50. And you start seeing that shape of an exponential function, which is what we have going on here. It should look like that. All right, so my lines are going off, but you do better than that because you're not doing it on a computer thingy. All right, so there is my function right here using an explicit formula. And then here is my graph of this. All right, so here's one for you to try. The answer will be up in 3, 2, 1. All right, so here's what I got for my function. Make sure you're writing that in function notation. I made a little quick T-chart, and there is my graph. It should look something like that. All right, that's all I got for today. So that's the end of Chapter 7. So you can be looking for a test coming up shortly. Hopefully you took good notes. I will see you all in class.